how to solve equations on trigonometric graphs. The first thing that you need to be confident with is the sine, cosine and tangent graphs. As you can see here, you need to know the properties of each type of graph, where it crosses the x and y axes, and the key points in each bubble on the right hand side here. So example 1 is asking us to find the values of x for which sine x is equal to this decimal. As you can see, I have been given a range for my x-axis between 0 and 360 degrees inclusive. Okay, so in this question you will have a calculator. The first thing that we need to find out is, as we are being told that sine x is equal to 0.9397, the first thing we need to do is actually find out what angle that is true for. Now, to do this, we need to do inverse sine. And this is always your first step in these types of questions. So if you type that into your calculator, inverse sine of 0.9397, we get 70 degrees. Now, as the sine graph repeats itself every 360 degrees, this cannot be the only value that x can equal. And that is what the question is asking you. It's asking you what other values can x be. So our first answer is 70 degrees. We can now use the graph and the symmetrical properties of the graph to find any other values for x. So if x equals 70 degrees, and if I go up on my x-axis, so I'll find 70 degrees is around here, and I need to draw a line that's going up and across. Now, sine x is equal to 0.9397. That is what that means. If we have a look at how far I've travelled on the x-axis to get to 70, well, it's 90 degrees subtract 20 degrees to equal 70 degrees. And this graph is symmetrical. So now I can travel along at 0.9397 to see if my straight line will touch another point on the graph. As you can see, I'm drawing a straight line from 0.9397 and I touch the sine graph here, so I need to go down. I need to figure out what angle is x equal to here. Because the graph is symmetrical and 70 degrees is 20 degrees to the left of 90, to find what angle it is here, I can just do 90 degrees plus 20 degrees. That's going to give me 110 degrees. And you can check your answer. If you type into a calculator, sine of 110 gives you 0.9397. So the other answer, x equals 70 degrees, and x can also equal 110 degrees. You can see from your graph that if I continue that straight line, it cannot touch the graph at any other point. Now that is because it's been given in a range from 0 to 360 degrees. So you are ignoring the left-hand side of the graph. This range here is very, very important. Moving on to example 2. This time round, I'm focusing on the cosine graph. So I've copied the cosine graph underneath the question to help us. Again, I've been given a range. X is between 0 and 360 degrees. So I'm looking between these points here. I'm ignoring the left-hand side of the graph. I'm being asked to find the values of x for which cosine of x is equal to negative 0.6691. So if cosine x is equal to negative 0.6691, I can find for which values of x, or which value of x, sorry, that is true for. So again, I need to find inverse cos. If you type that into your calculator, inverse cos negative 0.6691 is equal to, if I ran my answer to the nearest degree, and then that will actually specify in the question, 132 degrees to the nearest degree. Okay, I'm going to do the exact same steps as I did for the sine graph. So one of my answers is 132 degrees. So I need to go to my graph and see whereabouts 132 is. Well, 132 degrees is about here. Draw a line down and go across. So that's equal to negative 0.6691. Now, if I extend that line to see where else it touches the graph, I draw a straight line across here, and whenever I touch the graph, I draw a straight line up. Now I need to find what the x value is equal to at this point here. Again, using the fact that the cosine graph is also symmetrical, it repeats itself every 360 degrees. Well, I can see from 90 degrees, this is 132. And the graph here is symmetrical. So actually the distance is the same from 90 to 132 compared to 270 to this arrow here. So the difference between 90 and 132 degrees is 42 degrees. So to find this point here, I just need to do 270 degrees subtract 42 degrees. 270 subtract 42 is equal to 228. So this point here must be equal to 228 degrees. So my second x value is 228. Again, check your graph. Does that straight line intersect the graph at any other point within the given range? No, it doesn't. So they are my only two possible values. And again, you can check your answer by typing cos 228. That will give you negative 0.6691, which matches the question.